Yes, sir.
Okay.
Yes, sir.
So all fine. Good
Yes,
evening,
sir.
everyone. Chaliye, let's start. So I think you all are here for Verilog. Okay. So what we will see in Verilog, that is a different story. And what is the syllabus? What part is important? What part is tough? What part is easy? So just a second. Just a second. I'm missing my S pen. Sorry, just a second. Hanji, yes, I have. So what part is tough? What part is easy? So these all are different story. But first of all, my agenda is so you should know why very long. That means we have mathematics, we have C, we have other programming languages, we have subjects. But why very long? Okay, so that is the main part. So first, you should know answer for this question. Then only there is a meaning of talking about those things.
Share
कि
the screen
what,
also. Share the screen also.
just a second, I'm saying. Okay, चलिए start कर लेते हैं.
बस शुरू मुझे लैपटॉप चाहिए.
हाँ जी. Okay, so I think you can see my screen also. So I was talking key that is a different story. What is very log, what part is important, and other things. But first, my question is why very log? Why very log? क्या ऐसा हो जाएगा after learning this? You will get a opportunity in the industry, and they have a even huge requirement. So what is special in it? What is the requirement? क्या ऐसा है जो इससे नहीं हो पा रहा है? That means life with Verilog and without Verilog. That means life with Verilog and without. So first you should know these things. पहले ये तो पता हो, right? So first of all, we will see answer for this question. And before starting this key why Verilog, I want to tell you the overall flow with respect to technology wise. That means what is happening in the industry. बिकॉज आपने शायद बस एक ही नाम सुना होगा, VLSI VLSI VLSI. ज्यादा से ज्यादा you know only the full form. And if a few of you are doing masters or completed master in the VLSI, then I think you have enough idea from some IIT or some other campus. Then you have enough idea. That's fine. But if you did not, okay, so some of you might working or some of you might be tech students. So that's why first of all you should know the actual flow. ये VLSI 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 ये क्या है? हाँ हाँ पैकेज मिलेगा. That's fine. But why? ऐसा क्या है इसमें? Okay, so first I want to show you the overall look for this. चलिए, so try to understand. We have a customer. हाँ जी, so हाँ जी, sorry. So we have customers. अब what is a customer or who will be our customer? So customer could be anything. Like in a company or in a building, let us suppose we have a director room. अब director room में we have 3 rooms, or sorry 3 door. उसमें 3 डोर हैं भाई, D1 है, D2 है and D3 है. So who could be the customer for a digital engineer? So let us suppose customer came to you and customer saying, please give me a circuit. Please give me a circuit. And what are the specifications of that circuit? Let us suppose if D1 and D2 are turned off but D3 on, then please give me a fire, a alarm, a alarm. मतलब जब मेरा D1 D2 ऑफ है और D3 ऑन है, ये सिचुएशन कभी नहीं होना चाहिए. So we can say D1 D2 is they are protected doors which director can only on, but D3 can anybody on. So if D1 D2 are off and D3 is on, so hence it's a proof, or the statement is like that, director is not available but D3 is on. That means something is wrong. So it should give an alarm. So I'm not interested in the circuit functionality, but I'm interested like that there might be many requirements. ऐसी बहुत सी requirement हो सकती हैं, और उसी का मैंने example लिया है. This is a circuit, let us suppose, and this is a very simplest circuit, but it could be a complex circuit also. सर ये कुछ भी बता दिया है, एक realistic example बताओ. I think you have in your hand that is a calculator. That is a calculator. What calculator do, or what scientific calculator do? So you should give a operator and you should give 2 inputs. Let's put 2 and 3 and multiply. You should get 6. This is also a circuit. It could be scientific calculator also, like sine theta. So you should give theta value, you should give sine here, then you should get value, right? Let us suppose you are giving here 90 degree. So I think sine 90, 1. Okay, so circuit could be anything. So now what a digital design engineer will do? Okay, so digital design engineer will do something, and most probably he will make a table of inputs and outputs. Okay, of inputs and outputs, and finally he will find out the relation between input and outputs, like that sum equals to a XOR b XOR c. सर ये क्या अचानक से लिख दिया? ये वही है, एक सम या एक एडर भी एक आपका सर्किट हो सकता है. And let us suppose in the director room, so we can say these are D2. Sorry, it should be when D2 off, when D1 off, but D3 on, then it should give an alarm. ये भी एक सर्किट है. But these are expressions, these are not circuits. So circuit could be in the form of this, in the form of gates. So finally जो डायरेक्टर वाला एग्जांपल था उसका कुछ ऐसा होगा. So customer came to you and you will give this one. So you will give like this. So when D1 on, when D2 on, but D3, sorry, D1, D2 off, but D3 on, then you should give an alarm. That means Y. So it could be circuit. So finally, we have this circuit in the form of gates. Okay. So finally, we have a circuit in the form of this. Now, finally, we come to the conclusion. We have in our hand some digital circuits. Okay. So first we have customer. Then we have circuit in the form of gates. Okay, in the form of gates. Now, if I am drawing this, so think in realistic way. This is a image. ये तो इमेज है ना, इसमें यहाँ पे मैं टच करूंगा तो मुझे वोल्टेज नहीं मिलेगा ना. So that means this is a symbol of circuit, not actual circuit. So for this, how you will make a circuit? So it should be not gate के लिए कुछ ऐसा. So this is our not gate and this is also our not gate. तो दो not gate लगेगा इसमें and one AND gate. So it could be like this. So A है. So that means here I can say A, B, C. So this is A, B, and C. This is A, B, sorry, outputs and C. So that means overall, this is a circuit. This is a circuit. Sir, for me, this is also a symbol. Yes, you are correct. But this is a symbol for MOSFET. And MOSFET, you can have it directly as a device. You can purchase from market. Sir, वो क्या होता है? So if you cannot, then you can fabricate this. I think everybody know. So you can find out from the nature like NPN and you can draw some MOSFET. Okay, NPN and something like that, some channel width, and you can fabricate this from here. Okay, so overall story is like this. And from where you can get this, तो ये तो आपको नेचर से मिल जाएगा. सेमीकंडक्टर ये तो मिट्टी से मिलके बना है. मिट्टी इन द सेंस कि द नेचुरल थिंग्स विच आर अवेलेबल. ओके, तो यहां से यहां तक का सफर like this we have finally this circuit we can achieve. Okay, circuit we can achieve. Now what you will do? So you have this circuit and hence you will give this circuit in the fabricated form to the customer in the form of a device, like calculator you have. Okay, and that should have a circuit. So circuit I can draw like this, few inputs and few outputs. Okay, and what internally it have only those things internally. वही है, इसमें और कुछ बहुत बड़ी बात नहीं है. Okay, so I think ये मैंने उल्टा बना दिया, but that's fine. Okay, so like that we can have. So finally this is in our hand and you send it to the customer. So now you will not take this thing seriously because we are talking about a calculator, we are talking about a fire alarm, we are talking about a adder. So what happens if a customer comes to you for a processor? Processor is also a circuit. वो थोड़ा सा बड़ा है. Let us suppose i20. सर i20 कौन सा प्रोसेसर है? ये तो आज तक आया भी नहीं है. हाँ, so in future it will come. That's why customer come to you ना. जो circuit already available है उसके लिए design engineer क्यों आएगा? So design engineer will say to you for a i20 processor. Then again same story. You have a circuit for that. And what you will do? Let us suppose you send this circuit directly. So this is a processor. So let's suppose this is a processor. Okay, let's suppose this is a processor. Okay. Okay, so this is a processor. Now what happens here? You just listen customer requirement, and after listening customer requirement, you made a circuit. Okay, you made a circuit and you send it to the customer in the form of a device. Okay, so what happened in this? Let's come to a small example again. So let us suppose this is a adder. Okay, so this is A and B and Y. And Y will be Y equal to A plus B. Plus mean addition. Okay, not or operation, it's addition. Okay, so fine, or you can take this as a multiplication. So just think about it. If you are giving here 4 and you are giving here 3, so you should get here 12. Okay, you should get here 12. So you made a circuit properly, and what happens? You send this circuit directly to the customer. That means what you actually did. So customer comes to you. You made a circuit, and in the form of device, you send it to customer again, like A, B, and Y equals to A into B. So what happens now? Customer received this and paid to you some amount. But what happens here when customer doing use of this, then if user is given 4 3, then user is getting 12 here. But if user is giving 9 and 0, so user is getting 9. But if user is giving 6 and 3, so user is getting 18. But again, if user is giving 7 comma 0, so user is getting 7. So what I can conclude here, so this circuit is most probably not working if one input is 0. So that means it could be a gap from development side. That means it could be a bug in the circuit. इस circuit में कुछ missing हो सकता है. Okay. So what happens here? Now this circuit is not correct. This circuit is not correct. तो ये तो correct नहीं है. This circuit is not correct, not functionality correct. Now what happens? Customer again come, customer again come to the design engineer. वो design engineer के पास again आएगा. Then what design engineer will do? Design engineer will modify the circuit. Okay, so the one word is modify here. So you know what is the disadvantage or what the problem in this. So the problem here is it will leads to wastage of, even ki huge wastage of money and time. Money and time. So धन व समय का बहुत बड़ा नुकसान हुआ है यहाँ पर. Okay, so huge amount of money and time will waste here. Huge amount में. Okay, so this happens repetitively. Then what design engineer thought, why should I not verify this circuit before sending it to the customer? That means design engineer thought, I should validate this. I should validate this at my end. Then only I will send it to the customer. By this, I can build up a belief, as well as I can save the money and time. The money and time I can save. So hence, one more block will introduce in this. And what is that block? So that is nothing but verification, or I can say validation. Okay, so this is verification and validation. So now what happens from the next time? Let us suppose customer come for that director room circuit, and design engineer will make a circuit. But for this time, design engineer is very much aware, I need to do a validation or verification. I need to do a validation and verification first. Then only I will send the circuit like D1, D2, D3, and then Y. So now what happened with this? Because the circuit is already verified by design engineer, hence the chance of failure are almost zero. Why almost zero? Okay, So that is a different story that I do not want to introduce here. Okay, but still I can tell you one line. There are two type of defect. One is circuit defect, one is fabrication defect. Try to understand, your circuit is functionality correct, but at the time of fabrication, some dust particle comes. Then what happens? So connection might not happens properly. Hence, it can result into some bug, or it will not give exact output. Okay, hence I am saying almost, so that would be almost correct. Okay, functionality correct, just because of which, because he did just a validation, he did a validation. Now comes to conclusion. So how I can conclude key from now onwards the flow will be like this. First customer come to you, then design engineer will had to make a circuit. Okay, and it will not directly send that circuit to the customer. It will do a pre-validation or verification of the circuit, it is working or not. And after doing a verification, it will send it to the customer, and then will work properly, obviously. So now comes to this processor part. Just a second. So now comes to how to do a validation. So think about it. If you are a design engineer and you make a circuit, then how you will validate? Or just think about it. You are in your home, and your some guest or your family members are saying कि please make a 2 cup tea. Okay, prepare a 2 cup coffee or 2 cup tea. Then what you will do? Customer requirement come, then you will make a plan. And if you will directly send, then what happens? You might not add sugar, or you might add sugar in the huge amount. Okay, that means above the requirement, above the threshold. But if you will do a validation, or if you will do a verification before sending it to the exact customer, then the chances of error is almost zero. So how you will do validate? So how you will do validate? Haji, how you will do validate? So you will validate it manually. How? You will just take input and you will just take some outputs. So you will take input as a T and you will revert like about the taste, how it is. Okay. So here also, like if you are making some adder, so how you will do? If you are making some adder, so you will give different combinations of value, like 4 0, and if it is y equal to a cross b, then it should give 0. If you are getting 3 and 4, it should give 12. That means you will do verification manually. All right, you will do verification manually, and which is almost impossible. So you will just give inputs and you will just check outputs for almost all combinations, which is possible. Okay, and let's suppose if this is a director rooms, so how you will do validation? You will manually give some inputs like d1 d2 as a 0, they are turn off, and d3 as a high, that is turn on. Okay, so you will do manual verification. Haji, sorry. So you will do a manual verification. Finally, we can conclude. Now comes to that example. Now comes to that example. So, which is a processor. So now let us suppose one customer came to you and he is asking for i20 processor. So what you will do? Similarly, you will make first a circuit, and then now you will not send this device directly. Okay, what you need to do? You need to add one more block in between this, and that is nothing but a verification. Okay, that is nothing but a verification, and then you need to send this. By adding this block, what happens? The error the error will not come into the device, or your device will work properly, right? But can you imagine? Can you imagine verification of a processor manually? Is it possible? That means manual verification, manual verification of a processor. Can you imagine? Okay, so manual verification of a processor. Can you imagine? Can a human being give inputs like what a laptop or what the memory and rest of the things will give as input? And there are huge amount of inputs like 2 to the power 500, kind of like that. So which is almost not possible. Okay, so here verification is manually not possible, right? So here verification is manually not possible. So now if something is not possible manually, then what is the next step? So the next step is to take help from computer. So here what is the option? Then we will do verification through computer. Now how you will do a validation from computer? Try to understand. You make a half adder circuit. ठीक है? Half adder कहिए या let us suppose you made a not gate. Sorry. That let's suppose the data circuit like that I made. Okay. So let us suppose this you made. Now, how can you verify this? Will you draw this circuit into paint? Will you draw this circuit into this whiteboard? And then will you verify? Answer is no. Then how can a computer understand this hardware circuit? How? So that means here we have one challenge. What is the challenge here? Manually we cannot verify, and we have to verify. And with the help of computer, we want to verify, but computer cannot understand these MOSFET, this gate, NOR gate, AND gate. Computer cannot understand. So what we can do? We have a challenge here. So because computer is only know 0101, computer is only know binary language. So what is the option with us? Hence, we need a mediator. We need a mediator. Sir, what means mediator here? Try to understand. In one hand, we have this circuit. In one hand, or we can make it just a symbolic diagram. I think you can understand that things now. So we have this circuit in one hand, and at the another hand, we have a computer that can understand only 01010101 like that. Or we can say a computer can understand instruction. Or we can say a computer can understand set of instruction. Or overall, we can say set of instruction is nothing but a program. So that means a computer can understand a program. Or we can say this the information can understand by computer, that could be in the form of a language, and that could be a programming language. program language. So now in one side we have this symbolic circuit, that is a electronic circuit, that is a digital circuit, and on another hand we need information in the form of a programming language. Then how to do a mapping? So overall, holistically or collectively, I can say we need to do something. We need to do something. If I have a digital circuit and that circuit equivalent word is most important here. That equivalent in the form of program. That means this circuit I want equivalently in program, in programming language. Why? Because I need to do verification first. Sir, no issue. Directly you can fabricate and you can send it to customer. What happens if there will be a bug? So customer will come to us. Try to understand. Intel is giving some processor to you and you are purchasing a laptop. And if you are finding a bug, you are removing local disk D and local disk E removed. Then what happens? Even you will file a case to the Intel. Okay, so that means that without verification you cannot send. You do not have that option. You have to do a verification. But if you are doing a verification, that then you have a challenge. For a smaller circuit you can do a manual verification, but for the CPU or like such a big design you cannot do a manual verification. That is a problem. So I conclude my challenge to I need to do verification through computer only, but computer can understand a programming language, but I have in my hand that is a digital circuit. So how I can send a equivalent thing? How I can send? So this is something we need. This is something we need. How I need? That means digital is a hardware. So hardware equivalent into program. Okay, hardware equivalent into program. So this is I need. But what I can write one more statement here, or I can say what is my requirement, a how I can describe a hardware describe in program. Or I can say I need something, some language that could be that can be do hardware description in language. In short, I can say this is nothing but HDL, which is hardware description language. So I need a language, and what should be the job of that language? So that language can describe a hardware in the form of language. So that means I need a HDL, and that could be uh, a collection of library. Okay, so the collection of library which can do the job of describing hardware in the form of language, and that is nothing but a Verilog. So Verilog is a language. Verilog is a language, and that is a programming language which can do which can describe the hardware in the form of language. That means Verilog is a HDL. Hence, I can write here. I need to do verification through some HDL. Okay, or I can say Verilog. So this is the requirement of Verilog. Try to understand life with Verilog, life without Verilog. So without Verilog, you cannot describe your digital circuit into the program, and you cannot verify your circuit through computer, and manual verification is not possible. So that means the circuit which you will send, the device which you will send to the customer, that will be uh, not bug free. That should have some bug. Okay, so that is what a life of a design engineer without Verilog. But with Verilog, what he can do? He can directly describe the digital circuit in the form of program. एक डिजिटल सर्किट को प्रोग्राम में डिस्क्राइब कर सकता है, and then what he can do through through computer, he can verify the circuit. And finally he can send it to fabrication, and that fabrication, after fabrication, the device will not have any error. That would be error free, and hence by this he can save time as well as money. Time as well as money. So what I answered here, I taught you the overall flow, and what is the necessity of Verilog. But in this overall things, we did not saw what is VLSI. So actually VLSI is not a language, VLSI is not a circuit, VLSI is not a device. VLSI is a technology. VLSI. So VLSI is a technology, and that means very large scale integrated circuit. Okay, so that means whatever device you are making, if that device have very large, kind of in millions, let us suppose if in millions, if you have your device or your processor have gates in millions, okay, then we can say that will fall into a category of VLSI technology. So that is a technology. Okay, so this is the overall flow. Like customer come to you and you need to make a circuit. Okay, and that circuit should verify before fabrication, and that verification you cannot do manually. Hence you should have something, so that we can convert. Okay, so that we can convert it into the programming language and then manually verify, right? So that is the necessity of Verilog. So this is the first part. You should know what is the necessity of Verilog. Now, in the second part, what I want to show you, this exact thing for a small circuit. How you can do this? So, what is the smallest circuit? The smallest circuit is half adder, and I hope you can listen me properly. Can anybody confirm?
Yes, sir.
Yes, sir.
Okay, thanks. Okay, चलिए. So we can take a smallest circuit example. ठीक है जी, just a second. So smallest circuit example could be a half adder, but I want to take some other circuit instead of half adder. Let's suppose one customer came to you and he is asking, please make a mux. Okay, please make a chip, a IC that could be a mux. Okay, so how mux behave? This is I naught, and this is I1, and this is select line, and this is Y. Okay, so this is what? This is a hardware. Okay, hardware, and I made this hardware as per customer requirement. Now what I need to do, I need some equivalent of this, or I need the description of this hardware. मुझे इस हार्डवेयर का डिस्क्रिप्शन चाहिए प्रोग्रामिंग लैंग्वेज में. Okay, so how can I describe this? Okay, so syntax wise you should not worry now, because you do not know the syntax. Okay, and just see how we will. So some kind of module and module. Okay, so these are the syntaxes. And first of all, I want to just in one line I can tell you how we can define that a language. So language is nothing but a some set of instruction only. Who just library is nothing but uh, Verilog developer gives some instruction. Like if you are getting a keyword, and so that means it should be y equals to a comma b, something like that. Okay, something like that. Let me set of instruction. Okay, so you should not worry about at this stage. In the very first day, you should not worry about that. So here it could be mux of 2:1. Okay, and you can give some inputs like I naught comma I1 comma S comma Y. Okay, and you can define like inputs are I naught comma I1 comma S, while output is Y. And just you can define like assign you can assign this Y equals to S, this colon B colon A. So what is this? This line is nothing but a description of this hardware, a description of this hardware in the form of program. That means whatever I am writing in this box number 1 and box number 2, both are equivalent. ये दोनों एक दूसरे के equivalent हैं. Whatever I am defining in this hardware, that I describe in the form of programming language. How I described, why I am taking module, why I am taking here I note I1 S1, that we will see in the entire subject. Don't worry about that. But first you should have that imagination. हम करने क्या वाले हैं? That imagination is you should have very clear. Okay, and then how you will verify this? We will see how you will verify this. We will see. Just a second. So that means data type. Okay. So I can show you. How we will do. How we will do the verification of this with the help of a computer. So just see here, I am defining the equivalent of that hardware in the program. Okay, usi ka. So let's suppose this is my design module and end module. Okay, and that I can write here mux. So which I wrote in the box. So you can just see here how many inputs I have. I have 1, 2, and 3. And I have 1, 2, and 3 inputs. How many outputs I have? I have one output. I have one output. How many total ports I have? How many total ports I have? 1, 2, 3, 4. I have 1, 2, 3, 4. What is the name? The name I wrote here, mux of 2:1. The name I wrote mux of 2:1. And this is the exact equation. That is the exact equation. Right? So this is very equivalent. That means total hardware described in the form of a language. Okay, so let's see. This is mux of 2x1. Okay, 2x1. Now we can have I note comma I1 comma S comma Y. Okay, and then I can say out of these ports my inputs are I note comma I1 comma S. And my output is y here. My output is y here. Okay, and here I can say some assign y equals to s of, that means if select line is 0, then it should have I of 1. Okay, and otherwise it should have I of 0. Okay, don't worry about this. So this is design. So I should give appropriate inputs also. Okay, to this design I should give inputs also. So input also I will give through the tool only. So which is a module PB. Okay. Don't worry about this name and syntax. Don't worry. मैं ये पढ़ा नहीं रहा हूँ. मैं just imagination create कर रहा हूँ. And module. I'm not teaching you how to write the code. I'm just showing you the key how we are describing. Okay. Let's suppose this is we have Raj of I note comma I1, and here I can give some wires of Y, and here I can do instantiation of x of 2 cross 1, and I can do here mapping as I0 comma I1 I0 comma I1 comma select comma Y, and it should also have that select line. Okay, and some initial. Don't worry what is this initial, what is this begin. I'm not teaching you right at this time. I'm showing you how equivalently I can define and how I will verify. I want to just create that imagination. वो important है मेरे लिए. Okay. So first of all, I can give some combinations here, like has of 2 I can write here, and then I'm giving my select line as 0 and I of note equals to 1 and I of 1 equals to I of 1 equals to 0, and then y is the output. So this is I can do for multiple times. Okay, let's suppose I'm verifying only 4. So 1 is for s equal to 0, and this is for s equals to 1, s equals to 1. So when s equals to 0, it should be 0, 0. Okay, and it should be when it is 1. I'm getting 1, I'm getting 0. Yes, that's fine. Okay, and here I can just write $display. Don't worry about these things. I'm just creating imagination. I'm repeating multiple times. Not equals to okay. So let's see. So we will get this in the form of like a truth table. हाँ जी. Sorry, just a second. हाँ जी. So Hanji. So can you see here how I did verification? So when my s is 0, okay, so that means if my select line is 0 here, so if my select line is 0 here, then what it should give? So whatever I have at I node, that I should get. Let's see, are you getting the same or not? So whenever your s is 0, so whatever your I not have as a 1, so you are getting y as a 1. In the next case, whenever your s is 0 and your I naught is 0, so you are getting y as 0. And in the next time, if your s equals to 1, then whatever you have at I1, the same you should get in the output. And here also s equals to 1, and this is I1 equals to 0, and the same you are getting I equal to 0. Sir, I understood this table, but I did not get what you taught us here. What you taught us here in this all. So you are thinking in a wrong way. I did not taught you this. मैंने इसमें कुछ पढ़ाया ही नहीं है. But what I taught you, how we can describe this diagram equivalently in the form of a program. That imagination I am showing you. You should have that imagination. And that is the power of a Verilog language. This is the power of Verilog. Through Verilog, it is possible. So that means we can describe a hardware in the form of program. That is nothing but a Verilog. You understood? So I taught you only two things. One is what is the necessity of Verilog, and second is how we that imagination, how you can see the description of a hardware in the form of program. Now, as a part of theory, I can taught you, or I want to taught you one or two things from the starting. Okay, so that you can have idea how the flow will be for our Verilog. Okay. And first of all, I should discuss about index, what we need to see, but I think those we will see later. We do not have enough time today, and we are not in that phase. Okay, so obviously I will show you first that index, what part we will see, how the labs we will see, how the program we will see, what project we will done, how we will do, how theory will be. Okay, but before starting that, I want to skip this part as of now, and I want to give you a small idea on how I will explain my theory. Okay, how theory we will see how theory of a Verilog. So first of all, try to understand we have a hardware. Okay, we have a hardware, and we need to do a equivalent. That means we need to describe this in the form of program, in the form of these lines. This is a hardware. Okay, in the form of lines. So we should have some set of rules. Okay, we should have set of rules, and out of those rules, I am taking a smallest part or the first part of that rules. So this is a hardware. So in the hardware, we can have two types of things. Just say if I'm talking about this input, okay, this input if I'm talking about, so this input can store some voltages, or this inputs can bypass some voltages. So sometimes I need to store a value, or sometimes I need to pass a value. Hence, equivalently, we should have something in our languages. So, what example I can give to you in the realistic way? We need some container so that they can contain some value. Okay, so in the circuit, I think you can see if you are giving a 5 volt, so there are two possibility. Either that 5 volt can contain by the device, or either the device can bypass it, transfer it. Okay, so that means to store something or to bypass something, we need some equivalent, and the equivalent of those is nothing but a data type, and they are available in almost all programming languages. But I want to tell you first what mean by the data type. What mean by data type and why we need data type. So First of all, what mean by data type? So just try to understand, we are making some container and some different container so that they can contain a different quantity and a different type of quantity. Like even realistic way, we can have a container for a milk, a container for a gas, and a container for a solid. Okay, so how I can say to you, there are two types of container. One is liquid container, one is solid container. Okay, so one is liquid container, one is solid container. Now if I am writing here liquid, and if I am writing here bottle, comma glass, comma bowl, etc. So what mean by this? The mean by this is bottle, glass, and bowl. They are container which are of liquid type. That means they can contain liquid. And let us suppose I am writing here gas. Okay, so I can write here some cylinder. Okay, and some cylinder, some pipe, and etc. Okay, or we can say some cylinder and some balloon भी लिख सकते हैं हम यहाँ पर, right? So what are those? So balloon and cylinder are nothing but container, and they can contain gas. So cylinder and balloon are container which is of gas type. So what is the data type actually here? So a container which can contain the type of data, that means जिस टाइप का डेटा वो स्टोर कर सकता है वही उसका डेटा टाइप है. So try to understand, a bot can contain liquid type data, hence the data type of bot is liquid. So from here only data types word come. A container can contain which type of data, that type will become data type for that container. So in this case, bot is a variable which can contain liquid type. Hence, liquid will become a data type for this bot. So bot is a container which is of liquid type. Okay. So there are two types of container. One is storing container. So there are two type of container. One is store and one is to bypass. One is store, one is to bypass. Sir, I did not get this. What is this store? What is this bypass? So I think you all visited at least once a petrol pump. So petrol pump have some tank, and petrol pump has pipe also. So now try to understand, tank as well as pipe, both are container and they can contain liquid. Okay, so both are container which is of liquid type. But what is the property of tank? What is the property of pipe? So pipe is used to bypass, or tank is used to store. Tank is used to store. Sir, I did not get this point. Can you give some different example? Yes, I can give. I think you all are aware of a battery. Okay. So what is the battery? So let's suppose I am taking here battery, and here I am taking an electrical wire. So battery can store some charge. Battery can store some charge, but electric wire cannot store a charge but can transfer. Electric wire is used to just transfer. Electric wire में अपना charge नहीं है. Electric wire do not have its own charge. Electric wire do not have its own current. Electric wire can use to bypass the charge, but battery can store charge. पेट्रोल पंप पे जो टैंक है, okay, that tank can contain petrol, but pipe cannot contain. Pipe can only use to transfer, to bypass. Okay, so there are two types of container. One is storage, one is bypass mainly. So now the similar examples, or similarly, we can come into the our Verilog language. Hence, let us suppose I am writing here integer, and I am writing here a comma b comma c. So what are these a comma b comma c? A comma b comma c are container which is of integer type. Sir, what mean by this? The meaning of this is a can contain 23 because 23 is integer. A can contain 45 because 45 is integer. But A cannot contain star comma colon this because star comma colon this is a string. This is not a integer. Sir, B equal to 0.25. It is possible? No, it is not a integer. So what mean by integer data type here? Because A, B, C can contain the data which is of integer type. Hence, the data type of ABC will be integer. Let us suppose I am writing here a string a comma b comma c, or I am writing here a real a comma b comma c. Hence, ABC will become variable or container which would be of string type. They can contain only string. They can contain only string. The equivalent I can show you a bottle. A bottle equal to LPG, which is not possible. A bottle cannot contain a gas. A glass cannot contain a gas, but a glass can contain milk. A glass can contain water. So that means the data type of glass and bottle would be liquid, right? Equivalent I can show you here. Okay. So finally, we have data types in Verilog also. So how to define data types? A container which can contain which type of data. So that type will be nothing but data type for the same container. Okay. So now similarly, as I already told you, there are two types of there are two category of data type. One is for store, one is for transfer or bypass. So similarly, here also we have two category. One is register and one is net. Okay, so we have many category here also. Okay, but one of them I will tell you only one. So one of them is nothing but reg, and here is wire. Okay, and dot 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 dot. So what is a reg and what is a wire? So reg and wire are almost equivalent to what I already explained. So the reg is equivalent to a tank of petrol pump, and it is equivalent to a battery. But what is a wire? So wire is equivalent to a pipe in petrol pump and a electric wire in a electric circuit. Okay, so we have reg as well as we have wire. Sir, where we will use in the hardware? So try to understand. You have a circuit like this. You have a circuit like this. So now try to understand. Here you have A, you have B, you have C, and you have Y, and you have this W. So here A, B, C, and Y. We have option. Either they could be reg or either they could be wire, according to the situation. Okay, but this is the internal signal. It has to be of wire type only. Why? Because the job of this W is nothing but to transferring the output of this gate 1 to gate 2. Output of this gate 1 to gate 2. Hence we need mainly two types of data type. One is reg and one is wire. Or that means one is register, one is net type. Okay? And the equivalency you can get from that tank and petrol pump. So now try to understand. If somebody asks what is the difference in reg and wire mainly. Okay, so the main difference is in reg and wire. So wire need to continuously driven. Need to continuously driven. Try to imagine A electric wire needs to connect permanently through battery, then only you will get the supply. But what about that battery? So battery can store, and they do not need continuous driven because they have a storage capacity. So that is the main difference. So, sir, you mean to say you finished our data type topic today? Answer is no. Sir, you covered the RAS and wire today. Answer is still no. Then, sir, what you covered? I am giving you a idea of data type just. What is a data type? What are register, what are net, how they used, where they used, what is the property, what is the difference? That everything we will see later. But first I want to clarify the imagination. You should have that picture in your mind. Okay. So today mainly we saw three things. Why Verilog? And next one is that HDL and how we can describe and how we can verify. And now we need to learn Verilog, how we will be able to write the code. So you should know all the syntax and all the content of Verilog. So the part of that first part is you should have the clarity why, what is the necessity of data types and how actually they are. Okay. So I think rest of the things we will see in the next sessions, and obviously we will start from that index. Okay, what we will see and how the labs will be, how the project would be. So that we will start. Okay. So I think for today I did not target that. Okay. So now I'm done from my side. If anybody have any doubt, any questions, please ask. Hanji. So if anybody have any doubt, any question, please ask.